Alright, so for this lesson we're going to learn about the kinetic particle theory of matter. Alright, so actually scientists believe that all matter, solids, liquids and gases, they're actually made up of they're actually made up of particles. Alright, so there are certain assumptions for this kinetic particle theory of matter. Okay, the first is that these particles, so matter is made up of particles, very small particles that are too small to be seen. Okay, it is made up of extremely small particles that cannot be seen. Alright, okay, also there are actually spaces between these particles of matter. Okay, and the amount of space, okay, let me just write here. Okay, the amount of space between particles are dependent on which state the particles are in. Okay, so it's dependent on the state, solids, liquids or gases. Alright, in general gases, they are free flowing, okay, and they move about randomly, so the distance between the particles in the gaseous state are further apart than the distance between the particles in, say, the solid state, okay, relatively. Okay, the last assumption is that all particles of matter are in constant, okay, they are actually in constant and random motion. Sorry, in constant motion. Okay, let's just put it in constant motion. Okay, so they are in constant motion. Okay, so let us look at the particulate models of matter. Okay, let's go to the next page. Okay, in the model of a solid, okay, the particles will be packed closely together. Okay, the particles will be packed closely together. Okay, this is a two-dimensional view of, you know, how the particles in a solid will look like. Okay, they are packed very closely together. Okay, which is why they cannot be compressed. Okay, so particles in a solid. Okay, this is the particulate model of matter. Okay, particulate model of matter. Okay, first point. Okay, they are packed closely and orderly. Okay, second point, as you can see, little empty space between them. Okay, they are packed very tightly together. Okay, they can only vibrate about their fixed positions. So they can only vibrate about fixed positions. Okay, they cannot move freely. Okay, actually this point is an extension of the previous point. Okay, but if you look at the particles in a liquid, okay, the particles are okay further apart. Okay, let me just draw first and instruct later. Okay, particles are still close together, but they're not very orderly. Okay, by the way, the size of the particles should be the same, so this is not a very reliable drawing because I'm drawing it freehand. Okay, so as you can see, they are still packed close together. Okay, but it's not orderly. Okay, remember that it's not orderly. Okay, they still have very little empty space, although more than that of solids. Okay, but more than that of solids. Okay, the distance between particles has increased. Okay, and guess what? Not held in fixed positions. So instead of vibrating, what they do is the particles are free to move throughout the liquid. Okay, so the particles are free to move around liquid. Alright, okay, what about the particles in a gas? Okay, the particles in a gas really are far apart and absolutely random. Okay, so particles are far apart, absolutely random arrangement. Okay, and they're free to move anywhere in the container. Alright.